Hello everyone, in this video we will talk about counter current mechanism. First let me tell you what is counter and what is current. Counter simply means opposite and current means flow. So if a solution is going upward, the other will go downward. This is the opposite flow and this is counter current. Before understanding counter current mechanism, it is very essential to understand what is concentrated solution. So it's very easy. Concentrated solution are those solution which has less amount of water. Let's understand this from the example. Okay, suppose there is a solution and in that solution there is 10 liter water and 8 kg solute. Then this is lesser concentrated, and in another solution there is 8 liter water and 8 kg solute, then this is less concentrated, and then in third solution there is 5 liter water and 8 kg solute, then this is more concentrated. So what I told you was that one with lesser amount of water will be more concentrated, or we can say that the lesser the water, the more concentrated the solution is. The lesser the water, the more concentrated solution is. See how beautiful this diagram is. This is the structure of nephron. Now what is nephron? Nephron is the structural and functional unit of kidney, and these nephrons help us to produce concentrated urine. It is really very essential to produce concentrated urine, because if the urine is not concentrated, then all the water from the body, majority of water from the body will be lost. So body requires a lot of water. So to conserve water, we need to produce the concentrated urine, and this concentration of urine is actually done by the kidney. So this is the hairpin shaped Henle's loop. Okay, this is the descending limb of Henle loop and it is the ascending limb of Henle loop. Let's understand this from a simple diagram. This is the descending limb of loop of Henle and it is the ascending limb. How you will remember this? The limb in which the filtrate is coming downward is descending, and the one in which the filtrate is going upward is the ascending. So the descending limb is very poor, so it offers water to the medulla. From the descending limb, water is reabsorbed. Why? Because it is poor, so it can only offer water to the medulla. Remember it like that. And ascending limb, because it is very rich, so it offers electrolyte to the medulla. And this is what? This is U-shaped Henle's loop. Now let's see how concentrated urine is produced. Okay, this is afferent arteriole. This afferent arteriole brings 1100 to 1200 ml of blood per minute to glomerulus. Now all the essential components from the blood are taken away by this arteriole, this afferent arteriole, and this arteriole transfer all the essential component to the heart. Now there is a network of efferent arteriole which is called peritubular capillary, and this vasa recta is a part of peritubular capillary, and vasa recta runs parallel to loop of Henle. You can see this clearly from the diagram. Vasa recta is running parallelly to the loop of Henle. Now this is the descending limb of vasa recta and this is ascending limb of vasa recta. Now let's understand the concept of opposite flow. So opposite flow is taking place between descending limb of Henle loop. Here filtrate is coming downward direction and here filtrate is coming upward direction. So opposite flow takes place between a descending limb of loop of Henle and ascending limb of loop of Henle. Okay. Then where it is taking place? It is taking place between descending limb of vasa recta and ascending limb of vasa recta. and also it is also taking place between loop of Hanle and vasa recta. So it's take place between descending limb of loop of Hanle and ascending limb of vasa recta, and also between descending limb of vasa recta and opposite limb of loop of Hanle. So guys, per minute, afferent arteriole brings 1100 to 1200 ml of filtrate to the glomerulus, and all the essential components from the blood are taken away by efferent arteriole and they are supplied to heart. And only 125 ml of filtrate per minute remain for the glomerulus. Now compare this with the urine form per day. So the glomerular filtrate rate per day is 180 liter and the urine release is only 1.5 liter. Why this happen? Because most of the components and most of the water from the filtrate are reabsorbed. And why this happens to store and to conserve the water, as our body needs a lot of amount of water to function. Now as the filtrate moves downward through the descending limb of loop of Hanle, reabsorption of waters take place in the medulla. And as I told you earlier, the one which has lesser amount of water is more concentrated. So water is getting reabsorbed. So what is happening? Concentration is increasing as the filtrate is going downward. So initially the concentration was 300 milliosmol per liter. Then by the end of the descending limb, it becomes 1200 milliosmol per liter. So concentration get increased. Now as the filtrate moves upward through the ascending limb, reabsorption of electrolytes take place. So the concentration will uh, decrease. Why decrease? Because now electrolytes are removing out, so the amount of water will be increased. So by the end of ascending limb, concentration will become 300 milliosmol per liter again, from where we start, and the concentration will again become 300 milliosmol per liter. So that's why it is also said that in countercurrent mechanism, isotonic filtrate is converted into hypertonic form. Now as the filtrate reach to DCT, and because of deficiency of water in the body, two hormones act on DCT, that is ADH and aldosterone, and these hormones will lead to reabsorption of NaCl and water. That's why it is said that in DCT conditional reabsorption of water takes place. Again in collecting tubule, larger amount of water will be reabsorbed and a small amount of urea will also be reabsorbed to maintain the electrolyte balance, and the urine will become concentrated. So guys, through this mechanism, 4 times concentrated urine is produced than the initial filtrate is formed. In summary, we can say that in this way, Hanle loop and vasa recta plays a significant role in the formation of concentrated filtrate. Let me summarize you one more time. Afferent arteriole brings 1100 to 1200 ml of blood to the glomerulus. Now out of this, only 125 ml of filtrate comes to glomerulus because all the essential components are taken away by efferent arteriole and supplied to the heart. Now as the filtrate pass downward, then the water will get reabsorbed and the concentration will increase. Now as the filtrate move upward in ascending limb of loop of Hanle, because of reabsorption of electrolyte, concentration will again decrease. Now due to the deficiency of water in the body at DCT, two hormones will act, ADH and aldosterone, and reabsorption of water and NaCl takes place. In this way, conditional reabsorption of water takes place, and in collecting tubule, more and more amount of water will get reabsorbed, and reabsorption of a small amount of urea also takes place to maintain the electrolyte balance. In this way, 4 times concentrated urine is produced. So we can say that in this countercurrent mechanism, isotonic filtrate has converted to hypertonic form, and Vasarector and Henle loop play a significant role in the formation of concentrated urine. I hope now you have understood countercurrent mechanism very well. If you have any doubt, you can rewind this video. Thank you very much. Keep studying. Thank you.